Hey guys, Algebra 1, Topic 11, Student Activity Sheet 4. Okay, here we are going to connect our algebraic and graphical solutions together. Okay, so the first thing they want us to do here, guys, is graph this system. Well, I went ahead and I converted these both into slope-intercept form. If you're still having trouble doing that, head to office hours with your teacher and get some help. So right away, I noticed something. You may not, but when I graph these two lines, and I've got them color-coded here, I noticed they are parallel. They have the same slope, meaning they both rise to and run one at the same time. Okay. What do we normally say about this? We call this no solution. When when lines are parallel, there is no solution. Okay. But what happens if we don't solve this by a graph? If we have to solve this algebraically, okay, there's two ways we could go about it. These are the same problems that were on the previous page. This top one was our pink line, and that bottom one was our green line. Okay, just so you guys can see that. So I'm going to solve this first by substitution. Okay, I took those equations. Remember, step one is to isolate one of the variables. Well, I went ahead and did that. I turned this bottom equation. Why did I choose the bottom equation? Because the y was kind of by itself. All I had to do was add that 2x to the other side. So we are taking that y equals 2x minus 2. We are going to substitute it into the y. Here I did that. When I get down, I see my x's go away. They're gone. 4x minus 4x gone. I'm left with 4 equals negative 6. Well, guys, I don't know what world you're in, but in my world, 4 does not equal negative 6. It's not true. If I did this through linear combination, okay, I have to manipulate this second equation, okay? When I multiply that, I get that everything cancels over here. My x's are gone. My y's gone. 0 equals negative 10. Again, guys, in my world, 0 does not equal negative 10. It's not true, okay? What this means, when we get a false statement, there is no solution. What does that mean, guys? That means that our parallel graphs also were no solution. Okay? When we get false statements, no solution. False statements are parallel lines. Okay? Let's take a look at number 3. Okay? Now we're going to consider something else. Okay? When I look at this system, I'm going to graph these. I'm looking at these, and if I do the cover method, I get that x equals 6, y equals 3. Down here, cover method, x equals 6, y equals 3. What do you notice, guys? When I graph each of those intercepts, it's hard to tell, but there's a green and a blue line there. That's the same exact line. Okay, guys, they are the same lines. Okay, what did we say that solution is when they are the same? That means that there's infinitely many solutions. If an ordered pair satisfies one equation, it will satisfy the other. Okay, so what does that mean when using math, when using one of the algebraic methods? Again, I've got one of the equations solved for, and I'm going to substitute it into the other x here. And I get my variables disappear, but I get 18 equals 18. Well, guys, 18 does equal 18. That's true. Okay. When I use it down here, if elimination with the linear combination, I have to manipulate that top line. And again, my variables disappear. Everything disappeared. 0 equals 0. Again, guys, that's true. So when the variables eliminate and we get a true statement, that means infinite solutions. So same lines or a true statement. Same lines on a graph, or what we call a true statement, means infinite solutions or infinitely many solutions. Okay. And so then number 5 here, let's take a look at question 5. They want us to solve this system, and we're going to figure out what our solution tells us. So here's our equation. And I'm just going to go ahead and show this to you guys. It doesn't matter if you use substitution or the linear combination. Here I show you how I go through and do it. Okay. Again, doesn't matter which way I go, I get the same solution. My x is 12. My y is 5. What does that mean? That means that both systems result in one x and one y solution. That means there is one solution where these lines cross, and that is at the point 12, 5. Okay. Let's just summarize what we said here. Okay. When we have an answer, don't worry about these words over here, guys. Okay. Don't worry about that fancy stuff. We call it no solution if my graphs are parallel lines or we have a false statement with no equations. Sorry, no variables. Again, don't worry about that. We call it infinitely many solutions when it's the same lines that are graphed and a true statement with no variables. And again, don't worry about that fancy stuff. A single variable means that one single solution, when our lines crisscross in one spot, we get one value for each variable, an x and a y. Okay, have a great day.